In Chapter 9, Part 6, we are going to apply inequalities to application problems. So for the Spring Festival, the Math Club is selling rulers for $1 and compasses for $2.50. While the club would like to sell as many items as they can to raise funds, they need to make at least $15 to break even. So we're going to write an inequality to represent the situation. We're going to let R be the number of rulers sold, and C is the number of compasses sold. So we want to create an inequality. So we are told that each ruler is going to be $1. So we're going to have 1 R, so $1 per ruler, plus we were told that each compass is 250, so 250 times C, and that is going to be greater than or equal to our $15. So if we go back to the problem, it says that they want to make at least $15 to break even. So the smallest amount that they want to make is $15. So if they make more, then that's awesome, but they want to make at least $15. Part B says that school rules state that the club can sell a maximum of 25 items. So they can sell 25, no more than that. So we are going to write an inequality for this constraint or this limitation. So we know that we have the rulers plus our compasses, and this cannot exceed 25. So they can't sell over 25 items. So in Part C, we're going to graph what we just created, and we are told that the compasses, the C, is going to be our x-axis, and the rulers, the R's, are y-axis. So before we can graph these, we need to change the inequalities that we created so that they are set, so it's R is equal. So R is by itself. So I'm going to go back in Part B, and I'm going to subtract C from both sides. So R is going to be less than or equal to negative C plus 25. So we will graph that. And then up in Part A, again, we want to get the R alone, so we're going to subtract $2.50 C from both sides. So R is greater than or equal to negative $2.50 C plus 15. For my first inequality for A, we know that the y-intercept is going to be 15. So we're going to plot that point, and our slope is negative $2.50. So we could think about that as a fraction, be negative 5 over 2. So we're going to go down 5 units over 2 and find our next point. Now we got to be careful because this graph, if you notice the y-axis, it's not counting by ones. So we have like a notch, a notch, a notch, and then 5. So just be careful with that when you're going to graph. So I'm going down 5. So I'm going down from 15 to 10, and then I'm going to go over 2 units. Go down 5 more over 2, down 5 more over 2. And then we can graph this. This is a solid line because it is greater than or equal to. And then we can graph the other inequalities. So we have a y-intercept of 25. So I'm going to plot this in blue. And then our slope, we are going to go down 1 over 1. So we're going to go down 1 over 1. So we're going to plot those points. I apologize for my lines. I need a ruler, and it's hard to do this on the iPad, so bear with me. So they're both solid lines because they are included. So now we want to shade. So I'm going to use my trusty test point of 0, 0 because neither inequality is crossing there. So remember 0, 0 is right here. So I'm going to plug 0 back into the first equation. So that was my red. So 0 is greater than or equal to negative 2.50 times 0, which is 0, plus 15. So 0 is larger than or greater than or equal to 15, which is false. So I'm going to shade in the opposite direction. So everything to the right would get shaded because it was false. And then I'm going to plug 0 back into my other inequality. So 0 is greater than or equal, 0 is less than or equal to 25, which is true. So since that is true for my blue line, and that points to the left, I will shade to the left. So again, I'm using two different colors to see where they're overlapping because we're looking for the region that's going to represent both. So I'm going to use, let's say, green, and I'm going to shade where it is overlapping. So anything in this area here would satisfy both inequalities. So any of these points for R and for C, for the compass and for the ruler, would be true. So in part D, we're going to find the region of points that are solutions to each of them. Can this region fall below the x-axis or to the left of the y-axis, why or why not? So we highlighted in green what solution area would meet both of the inequalities. And the answer to the question is no. So if you think about it, can the region be below the x-axis? So down here, or to the left of the y-axis over here? It's going to be no, because you're not going to sell a negative amount of supplies. So we shaded the region, and then what do the points in the solution region represent? It's going to be the possible sales of rulers and compasses that would allow the club to break even or make a profit within that sales limit of only selling a maximum of 25 items.